Patterns. Sometimes steps in a process form a pattern. This is the bottom of page 588. You can describe some patterns with a sequence or an ordered list of numbers. Each number in a sequence is called a term. So sequence is the set of numbers. Each number in the sequence is called a term. So they're representing a snowflake here. Replace each little piece of the line with a line with a triangular shape above it. And so they've done this. They have this one line, and then they have one shape here, and then they've taken each piece and put each side here with that, and then they just keep going and keep going. And so, all right, so write the number of segments in each figure above as a sequence. And so for this one, we had one segment here. For the next one, we had 1, 2, 3, 4 segments. Here we had 16, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we're talking about every little segment. 64 for this one. All right. And so they want us to predict the next term. So if I were to do this again and every segment get replaced with this guy right here, they want me to predict my segments. All right, may not be able to see that looking at the picture, but when you write the numbers out, it becomes a little more obvious, right? We went from 1 to 4 to 16 to 64. What are they doing to go from one segment? Multiplying by 4, right. So if I were to assume what the next one would be, I would say it would be 64 times 4, which would be 256. And so that is my estimate that the next one here is going to be 256. The reason why is because it appears to be multiplying by 4. So if you'll remember in geometry, we did some pattern, and you were doing kind of an estimation based on a pattern. Patterns can change, so you have to explain why you chose your pattern. The reason I say that is I have had students give me a different number than what I assumed was the next number in the pattern because they saw a different pattern, but it was a legitimate pattern that worked for every single number that I had given them. And so that's why you have to explain your reasoning, because you don't just want to write a number, you want to then explain because I multiplied every number by 4. And then that's the reason that you put behind it. So try 1A, A and B. Describe the pattern formed, find the next 3 terms. This first one, you should have said you were adding 7, and it looks like this. What about the second one? What are you doing?
Divide by 3.
Divide by 3. Yep, you're dividing by 3. So your next 3 terms would look like this. Suppose you drop a handball from a height of 10 feet. After the ball hits the floor, it rebounds to 85% of its prior height. How high will the ball rebound after its 4th bounce? Well, if you look at this pattern here, 10 foot is the original height. After the first one, you multiply by 0.5. Second one, you multiply by 0.5 again. Third one, you multiply by 0.5 again. And fourth one, you multiply by 0.5 again. So 5.2 feet after its 4th bounce. Is there a pattern here?
Yes.
Yes. What are they doing? So look at this together. Yes, you multiply it until you get to the 7th bounce. So is there an easier way to do that? So let's look at it this way. For my 4th bounce, I had 10 times 0.85 times 0.85 times 0.85 times 0.85. Is there another way I can write this? To the 4th power, right? Yep. And this was for my 4th bounce. So then, is there an easier way to find my 7th bounce? Yeah, to the 7th instead of the 4th. That's right. Yep. Much easier than just taking one at a time. So when you find a pattern, finding a formula for the pattern is helpful. All right. Right below this, it says you can use a variable such as a with a positive integer subscripts to represent a term in a sequence. So like in this one we just did, the first term would have been a, and then we have this little subscript with a 1. So a sub 1 is usually how it's pronounced, subscript of 1. A sub 2, a sub 3, a sub n minus 1, a sub n meaning the nth term. So I can just fill that in with whatever term I want to. And what starts happening is here you start coming up with formulas. There's recursive, and then we're going to talk about explicit later on. Recursive formula is when you tell me what happens based on the number before it, okay? So if I were talking about that bouncing ball, you would say, well, if I want to find the nth term, then I am going to take the term in front of it, n minus 1, right? And I'm going to multiply it by 0.85. That's how I find the next term, okay? That's recursive. Recursive formula requires that you know the term in front of it, all right? If you don't know the term in front of it, then recursive is not going to help you. And so recursive just takes literally the term in front of it and then you do something to it. So we added 7 to one of our examples. You would say the term in front of it plus 7. That would be my recursive formula, all right? So then look at the next example. It says, describe the pattern that allows you to find the next term in the sequence. Write a recursive formula for this sequence. So what are they doing to go from 2 to 4 to 6 to 8 to 10? They are adding 2. So to do a recursive here, I would say my nth term, I'm going to take the term in front of it, that's a sub n minus 1, and I'm going to add 2. That would be my recursive formula. All right, it says find the 6th and 7th terms in the sequence. How many terms do they give us? 1, 2, 3, 4, 5. So to find the 6th term, I'm going to add 2 to the 5th term. That would be 12, right? Then my next term would be 14, right? Find the value of the term a sub 9. So a sub 9 takes a sub 8 plus 2. So what do I need to do first before I can find the 9th term? Right, what's the 8th term? I found 6 and 7, so that's going to be 16. So this term is going to be the 18. So find 11 and 15. All right, so for these, the 11th term was 22 and the 15th term was 30. Yeah, good. All right, so let's talk about this. They gave us this pattern right here. 2, 4, 6, 8, 10. And we kept going from there. So this would be my first term, right? This would be my second term, so on and so forth, okay? You can get from one term using the term in front of it, or you can come up with a pattern that gives you any term based on the term number, all right? So my first term was 2. To get to my second term, I added 2, right? So I started with my first term. We'll leave, started here, okay? And then from my first term, I added 2 to get to my second term. I added another 2. I added another 2. I added another 2. All right? So by the time I get to my 10th term, how many times had I added 2 to my first term? When I get to my 5th term, how many times have I added it? 4 times, right? What's another way to write 2 plus 2 plus 2 plus 2? That's times. That's, yeah, so 4 times 2, right? 2 to the 4th would be if I were multiplying those, not adding, right? 4 times 2, all right? 2 plus 4 times 2. That's how I get to my 5th term, right? Does everybody see that? So 2 is what I'm adding. 4 is how many times I added it, and I started with my first term. So I could say my first term, let's replace that with the first term, right? 2 is what I'm adding every time. That's the pattern I found, right? What is 4 in relation to the term that I'm on?
Number 4 times you've added it.
It's the term before it, yes. So if I were to write, if I am looking for the term itself, this is not the term number I'm on, right? It's actually 1 less than it. So how do I write 1 less than the term that I'm on if the term that I'm on is n? How do I write 1 less than n? N minus 1 times 2. All right? So now, what if I wanted to find the 11th term? What would I do? Well, I want the 11th term. That would be the first term plus 11 minus 1 times 2. So what's my first term? 2. What's 11 minus 1? 10 times 2. That gives me, is that not what we found when we just added 2 over and over? Right. This is called explicit formula. I don't need the term in front of it. I need the first term, right? That's all I need here is the first term. And then if I have the first term, I can give you any term that I want. Explicit formula. Now this is the explicit formula for this pattern, okay? Recursive formula means you need the term in front of it. Explicit means all you need is the first term. And then I can give you any term in the pattern.
So
right?
the 2 can vary.
This is an example of explicit formula. The 2 in the explicit formula will change based on what your pattern is. And we're about to talk about arithmetic formulas, arithmetic series. But this is an example of an explicit formula. Explicit means I know exactly what I have right in front of me. I don't need anything before it. Recursive means I need something in front of it. All right, this is an example. You can have explicit formulas for adding. You can have explicit formulas for multiplying. You can have explicit formulas for other types of patterns. This is an example of an explicit formula. This formula does not require the number in front of it. It only requires your first term. And once I know my first term, then I go from there. This specifically is an arithmetic series, all right? So that's what we're moving to is arithmetic series. Turn to page 594.